So today we discuss this Jacobi's methods of iteration. So two types of methods, numerical methods. One is the direct methods and other are the iterative methods. So what is the difference between direct methods and iterative method is that direct methods we apply only once to the problem, and iterative methods we apply again and again or repeatedly to the problem to find the solution of system of numeric linear equations. So the Jacobi methods is the simplest iterative method for solving linear system of equations. Ax is equal to b. Rearrangement of the given system is the key to method since it puts the equation into the form that is amenable to iteration. Amenable mean meaningful or suitable. At each stage of the process, new values of variables will be obtained by substituting old values into expression on right hand side of the given system. So here is the system of equation. It's a system of linear equations with the matrix of constants are minus 1, 2, 3, and three variables involved, x1, x2, x3. Okay, what's the first step is to just rearrange the system in a way which is amenable to the process. So rearranging the system, okay. In the first equation, we will write the first variable on left side, and from second equation we write the second variable, okay, on the left hand side, and in the third equation we write the third variable on the left side. Okay, so in this way, so 5x1, this is 5x1 is equal to minus 1 plus 2x2, okay, minus 3x3. 9x2 is equal to 2 plus 3x1 minus x3, and minus 7x3 is equal to 3 minus 2x1 plus x2. Okay. So x1 is equal to, we can write it 1 over 5 into minus 1 plus 2x2 minus 3x3. And x2 is equal to, so 1 by 9, 2 plus 3x1 minus x3. And x3 is equal to minus 1 over 7, 3 minus 2x1 plus x2. Indexing the system. So the next step is to index the system to make a formula. So x1 power n plus 1, you can also write k plus 1 is equal to 1 over 5 minus 1 plus 2 x2 power n. So on the right hand side, you have to use power n, and on the left hand side, you have to increase this power by 1 just to make a formula. Because if you put n is equal to 0, so this should be, the power should be 1. Okay. So to compute first iteration, set n is equal to 0, and the initial guess can be taken as x1 0, x2 0, x3 0 is equal to 0 0 0. So it gives, so when you put this 0 0 0, it will be like x1 1, x2 1, x3 1. So actually the subscript 1 is shown, this is the variable x1, x2, x3, and the power 1 shown that it is the first iteration. So just put 0 0, here you put 0 and you will get 0. Here is the 0, you will get 0, and 2 plus 0 minus 0. So then 3 minus 0 plus 0. So this will be equal to minus 0.2, 0.22, and minus 0.43. So to compute second iteration, set n is equal to 1. To compute second iteration, set n is equal to 1, it gives x1 power 2 is equal to 1 by 5 minus 1 plus 2 into 0.22. So for the second iteration, so this is the formula. For second iteration, you need to put n is equal to 1, so x1 power 2, and then n is equal to 1, 2x2 power 1, and 3x3 power 1. So now in this formula, you need to replace these values. So just look, x1 power 2 mean second iteration. 1 by 5 minus 1. So this is minus 1 and plus 2. Okay, x2. So where is x2? This is x2 power 1. So this value will be replaced with 0.22. So that is why 2 into 0.22 minus 3. This 3 and x3. So x3 power 1, because here is x3 power 1. So you replace this value here. Okay, minus 3 into minus 4.3. So then you will compute this first value, x1 power 2.06. And then x2 power 2 will be equal to 1 by 9, 2 plus 3, x1 power 1 minus x3 power 1. So 1 over 9, and then this 2 plus 3, x1. अच्छा अच्छा सही हाँ चलो बैठो अच्छा चलो सही है so x3 power this is you see 3x1, so x1 is 0.06, so 3 into 0.06 minus x3, this is x3 1, so minus into minus 0.43, so x2 second iteration will be equal to 0.20, and x3 second iteration x3 n plus 1, so n is 1, so it means 3 minus 2 x1 power 1 plus x2 power 1. So this it will be replaced with x1 power 1. So that is why we have here minus 2 into minus 0.2, this you see, and then plus 0.22 because plus x2 power 1, so x2 power 1 is here, replace here. So then you will see we calculate and we will get the values for second iteration. So to compute third iteration, set n is equal to 2. So if you replace n is equal to 2, you will get x1 power 3, x2 power 3, x3 power 3. So second iteration. So then x2 power 2 and minus 3, x3 power 2. And 3x1 power 2, x3 power 2. So you will get this, and then you need to replace these values with these values, second iteration. So 2x2 power 2 mean, so where is x2 power 2 is here, 0.200. This you will replace these values, minus 3 minus 0.52. So minus 0.52 is actually x3 power 2. So you have replaced these values, minus 3 x3 power 2, and you get here. Okay. So in this way, you will get this third iteration. So then fourth iteration, fifth iteration, and at fifth iteration, just observe that the x1 power 4 has values 0.18 and x1 power 5 has the same value 0.18. Okay, so it means, so if you subtract x1 power 5 minus x1 4, you will get on 0. So there is a 0 error or very minimum error. The similar way 0.33 is the same value. So when you get the repeated values, you can stop the algorithm. So that's why we can declare that this is actually the answer. X15 is equal to 0.18. You can also say that x1 power 4 is the solution because it depends on you. You can declare as the fifth iteration or the fourth iteration because both have the same values. So next is the Gauss-Seidel iteration method. It is similar with Jacobi method, but with a little bit changes. In numerical linear algebra, Gauss-Seidel method, also known as the Liebman method or the method of successive displacement, is an iterative method used to solve a linear system of equations. It is named after the German mathematician Carl Friedrich Gauss and Philipp Ludwig von Seidel. Gauss-Seidel method is a variant of Jacobi method that usually improves the rate of convergence. Gauss-Seidel method implements the strategy of always using latest variable value of a particular variable. So what's the difference between Gauss-Seidel and Jacobi method is that Gauss-Seidel use the latest available value. And the other difference is that Jacobi method compute parallel computation and Gauss-Seidel provides sequential computation. So again, if we consider the same example, you just make a comparison. So okay, it's a different example, not the same example. So we apply Gauss-Seidel method. The first step is the same, rearranging the system and indexing. So there is a difference between indexing in the Jacobi and Gauss-Seidel method. There is a only difference between the Gauss-Seidel and Jacobi method. So difference is only how to index the system. So in indexing, in the difference between Jacobi and Gauss-Seidel method is indexing. So in indexing, we make a little change. And so just observe here, xn plus 1 is equal to xn plus n plus 1 is 1 by 4, 8 minus 2 yn minus 3 zn. And now just observe that this first value is has been calculated here, xn plus 1. So then you need to put this value in the second one. And yn plus 1 is equal to minus 1 by 5. So since xn plus 1 is calculated, so you can replace here xn plus 1. But value of z is not calculated, so that is why you need to keep it as it is. And zn plus 1, uh, before zn computing zn plus 1, the value xn plus 1, yn plus 1 is already computed, so you need to replace here. To compute first iteration, set n is equal to 0 and take the initial guess as x naught, y naught, z naught. So then we compute this first iteration. So x1 is equal to 2. So now the difference is that we use this value here. You see, if just put n equal to 0, you will get x1, 2y0, 3z0, and y1 is equal to minus 14 minus 3 x0, x1, and z0. So since it is x1, so you need to replace this value here, you see. And z is equal to 0, so you can put this value here in 0. Okay, this 0 is actually this 0. Okay, and hmm, this 0 is also this one. Okay, but this 2, this value is this one. You see? Okay. So this will be computed in this way. So for y1, because x1 is computed here, so you can replace here. And for z1, so x1 and y1 is computed 2 and 4, 2.375. To compute second iteration, to compute second iteration, set n is equal to 1, it gives. So x2 is equal to 1 by 4, 8 minus 2 into 4 minus 3, 2.375 is equal to minus 1.781. Y2 is equal to minus 1 by 5 minus 14 minus 3 minus 1.781 minus 2 into 2.375 is equal to 2.681. And Z2 is equal to 1 by 8, 27 plus 2 into minus 1.781 minus 3, 2.681 is equal to 1.924. To compute third iteration, set n is equal to 2, it gives. So third, to compute the third iteration, if you make index, you see, for the third iteration, you need to change this n with 2 and you will get this third iteration. Okay, there, here it should be x3, y3 and z3. So there is a small mistake. So it should be x3, y3 and z3. So then we will replace the value accordingly. Okay, just go back. So this is the first equation. So for the third, x3 is equal to 8 minus 2y2 minus 3z2. So here is 2y2. So y2 is this value. Here is y2, this one. And we replace with this value. And this 3, this z2 is this value. Okay. So then minus 14 minus 3. So this value is computed here. This one. Okay. So we compute this iteration in the similar way as we computed this one. To compute fourth iteration, set n is equal to 3. It gives x4 is equal to 1 by 4, 8 minus 2 into 3 minus 3 into 2.017 equal to minus 1.062. Y4 is equal to minus 1 by 5 minus 14 minus 3 into minus 1, and Z4 is equal to 1 by 8, 27 plus 2 into minus 1.062 minus 3 into 2.969 equal to this one. To compute fifth iteration, set n is equal to 4, it gives this one. So we compute in the similar way. So just observe at the ninth iteration, the values are repeating. So x8 have the same value as x9 and y8 has the same value as y9 and z8 has the same value as z9. Since values are repeating, therefore the solution is x9 is equal to minus 1.00, y9 equal to 3 and z9 equal to 2. Solve the following system of linear equation. So this is the system of linear equation, rearranging and indexing the given system it gives. So again, so just observe now indexing is a different because they already these variable have the subscript, so you need to put as the superscript the indexing k plus 1 is equal to 1 by 10 x2k minus 1 by 5 x3k plus 3 by 5 and x2k plus 1 is equal to 1 over 11 x1k plus 1 plus 1 over 11 x3k minus 3 over 11 x4k plus 25 over 11. So similarly, x3k plus 1 is equal to minus 1 by 5 x1k plus 1 plus 1 over 10 x2k plus 1 plus 1 over 10 x4k. So to compute first iteration, set k equal to 0 and take x1 0, x2 0, x3 0, 4 0 equal 0 0 as starting values. It gives x1 1 1 by 10, x2 0, x3 0 plus 3 by 5.6, and x2 1 is equal to 1 by 11 x1 1, 1 by 11 x3 0, and this one. So in this way, we compute the first iteration. For the second iteration, we have these values for third, fourth, and this one. So in this way, we have computed the value. Similarly, for diagonally, so dominant matrices, so sometime Gauss-Seidel method and Jacobi method fails to give the solutions of the system of linear equation. So that's why we need to check whether the system is diagonally dominant matrices or not. If the system is diagonally dominant, then it must provide the solution by applying Gauss-Seidel method or Jacobi method. So what is the dominant matrices? A square matrix is said to be diagonally dominant if for every row of the matrix, the magnitude of the diagonal entry in a row is larger than or equal to the sum of the magnitudes of all the other non-diagonal entries in the row. More precisely, the matrix is diagonally dominant if aii greater than equal to aij, I naught is equal to j. So here is an example. Consider the following system of linear equation. This is the system of equation. So the matrix of coefficient is 3, minus 1, 2, 5. So this is a diagonally dominant matrix because 3 is greater than minus 1 and 5 is greater than 2. Is diagonally dominant. Second system is not diagonally dominant as matrix of coefficient is fitted with the second system. So 4 is greater than 2 plus 1, 3, and 0 is not greater than 2 plus 1, and 1 is not greater than 3 plus 5. So that is why the given this second system is not diagonally dominant. Our second system can be converted into diagonally dominant by interchanging second and third rows in the original system it gives. So if we interchange these two rows, uh, second and third, this one, so the system will become diagonally dominant. So example of divergence, sometime the system could be divergent. For example, if you consider the following system 1, 1, 1 and 2, 2, 1, so 1, 1, 2, 4, 4, 6. Augmented matrix of the above system is given below. By applying elementary transformation, so if we apply the elementary transformation, we will get the matrix of this form. So because the third row have contain all values of 0, 0, so system have no solution. Okay. So solve the system of equation using Jacobi method. So if we solve this system, we will get the answer like this one. Is that this is another example of Jacobi method, and this is the exercise. Okay, with the answers. So each question has its answers. You can solve and verify your answer with the given answer. So there are many questions for practice. So it depends on you how many questions you can complete. Okay, I can just revise. So first is the Jacobi method. The important steps are just rearrange the system and indexing the system. and then we will solve it. Uh, what is the difference between Jacobi and Gauss-Seidel method? Just the difference between is the indexing, because in the Gauss-Seidel method it used the latest available variable. Okay, and Jacobi is the parallel computation, use the parallel computation, and Gauss-Seidel use sequential computation, because Gauss-Seidel compute the way equation one by one. First, it computes first equation, then use this value in the second one. But Jacobi don't use this value in the second one. Jacobi use this value in the next iteration, and Gauss-Seidel use this value in the same iteration. So that is the difference. But Gauss-Seidel method is rapid than Jacobi method and very fast. So Gauss-Seidel is faster than Jacobi method. Jacobi method is slower, so not fast. So that is also the difference. Okay, so if you have any question, so then you can pose your question. Is there any question from your side?